first thing is to just a forecasting project folder, and you'll see two files. One is a forecasting project data set, and one is the forecasting project outline. So open both of them. So open the Word file and also open the Excel file here. And you need both of them to do the project. So let's just go over the project outline first. As you see, this is the data set that we're using for this spring semester. The data changes from semester to semester. So I just want to let you know that they have a different data set. So what we have here is a fresh detergent case, and what we're trying to do here is to forecast the demand for this product, and the variables we have are actually the demand, which is the Y variable, the price, which is the price of a fresh offered by Enterprise Industries. Average industry price is the average, competitor's price. Advertising is our advertising expenditure in hundreds of thousands of dollars. And the diff is actually the difference between the AIP and price. Okay, so this is what we have. So let's go over into the Excel file here and take a look at what we have here. So as you see, the data goes from May of 2013 to January of 2016. And the first step in Excel is to make sure that you have the data analysis under data tab. So if you click on data, you may or may not see data analysis. If you don't see data analysis, you need to go to File and click on Options, and under Options you see Add-ins. Click on Add-ins and go to Manage Excel Add-ins and click on Go, and you see these boxes, which is Analysis Toolpak and the Solver and other add-ins. Just make sure you click on Analysis Toolpak and activate that and OK it. After doing that, then you'll see under data, you will see data analysis. Okay, so we are ready to do the few first steps of the project. So the download the data from course Blackboard site, we already done that. And the second step is to make time series plot of all 5 variables. So it's actually very simple. If I go ahead and, I'm not gonna do the whole data set. I'm just gonna go do it till January 15. Let's just go ahead and do everything. If you highlight the column, just one column of demand data, and click on Insert, and then go under the chart types and click on Scatter plot, this is what you're gonna get. So this is just a basic graph. I want to make sure that you all go ahead and make this as nice as possible in terms of adding information in here. So if you press plus sign to the top right hand side, you need to go ahead and insert the access title. So if you click on that, then you'll see that you can actually type in the title. So the X title is going to be time period, and let's get rid of this part, and okay, and the y-axis, just delete that thing and just go back and input demand. Okay, so now we have the titles for the X and y-axis. What else we need to do here is probably go ahead and, if you go to one of the markers and right click, you'll see add trend line. So just go ahead and click on add trend line, and down below on the right hand side you see display equation on the chart and display r squared on the chart, and it will display these right here, and we have the equation and we have the r squared. We're going to talk about that later. Also, while we're here, just the title of this chart is going to be time series plot of demand. So basically, now later on you're going to have to explain what this chart or this plot is telling you. At this point, just right click and copy this graph and paste it in the Word file you already have. So everything we do in the Excel, you have to copy and paste it and bring it to the Word file, and that is the file you're going to submit as your teamwork. Okay, so let's paste it here. So go ahead. This is our first plot. It shows the trend line. It shows the equation on r squared. It has both x and y, and so that's one of the graphs. And you need to, after every graph, you need to explain this graph and what it's telling you, what you see in the graph. Yeah. So explanation of your work is very important. Going back to the Word file, let's see. That was one of the graphs. So we need 5 graphs. Let's see what is the next one. So after this, you can actually delete this or cut it. You don't need it anymore. The next graph is do advertising, and then do diff, and then AIP and price. So 1, 2, 3, 4, 5 graphs you have to do. Construct a scatter plot and insert the trend line in there and find the equation and then explain what this graph is telling you. The next step 3 is to construct a scatter plot of demand versus diff, demand versus advertising, and demand versus AIP, and demand versus price. Remember, demand is always going to be on the y-axis. That's what we're trying to predict as our dependent variable. So let's take a look at the data and let's do demand versus advertising, let's say. And this is straightforward. As long as you have your 2 variables right by each other in a column, it's very easy to construct a scatter plot of 2 variables. Now just remember that the first variable should be your x variable. So here I'm doing advertising as my x variable and demand as the y variable. So just go ahead and highlight both of them, and I'm just going to do all of it. Just going to do some of the data because I just don't want to give all the answers out. So let's say we have this advertising versus demand. Go back to the home and insert a scatter plot, and right here, there we go. This is our graph, and let's see, we can add our titles. For x-axis title, we have again advertising, and for y-axis we have the demand. Okay, and we have advertising versus demand. As our title of this plot, and then again just like before, you can right click and add trend line and display equation on the chart and display R squared. Here we go right here, and this is it. So again, go ahead and right click, copy the graph and bring it to the Word file, and again paste it here. So as you see, then you have to basically explain this relationship between advertising and demand. Just remember, these are not the correct answers because I did not use all the data points. Okay, so explain this. So that's one of the graphs. In a step 3, you have to do demand versus advertising, demand versus AIP, demand versus price. So 1, 2, 3, 4 graphs you need in a step 3. Don't forget that you just have to do demand versus diff. Make sure when you can put the columns right by each other in order to graph the scatter plot. All right, very good. So now we're done with the graphs, and you need to explain all your graphs. Then step 4 is to find a correlation matrix. Now, you all know correlation is the association between two variables, and the value of correlation ranges from -1 to +1, where -1 is called perfect negative correlation and +1 is perfect positive correlation. So let's go back to the Excel again, and I don't need this anymore. You can cut it. You can save it if you want somewhere in the Excel for yourself. But let's just go ahead and try to obtain the correlation matrix. So if I click on data again and click on data analysis, you'll see all these different statistical analysis tool we have, and what I need here is the correlation. So click on correlation, double click on correlation, and highlight. We're gonna highlight our variables. So I'm gonna just do it till January 15. I'm not using the whole data. Okay, so I highlighted the heading, and you need to don't touch this because the data is in the columns anyways, and label in the first is very important. To click on label in the first row, so Excel knows that the first thing it sees in a column is a heading and a label, not a data value. And the result, the output, you can put it on a new worksheet file, and let's call that correlation matrix. Okay, let me fix this thing right here. And so the data set, everything, I just use some of the data. We have to use all the data. And here we go, and click on OK, and here comes your correlation matrix. So what we really want you to do here is to explain this relationship between the demand and all these variables. Okay, so one by one you have to explain these values, like period versus demand. There's a, let's say, positive correlation. What does that mean? It basically means that there's a trend in the data. Price versus demand, there's a negative correlation. What does that mean in simple language? AIP versus demand, what does that tell you? Diff versus demand, positive. Advertising versus demand is a positive correlation. So you need to explain all these basically 5 values of correlation. So just go ahead and, again, just like before, copy the correlation matrix and bring it to the Word file, and right here, and go ahead and let's see, and paste it here so you can actually move it, I think. And there we go. So right after your correlation matrix, you have to explain what you've done here. Okay, relationship between demand and all the variables. So step 5, we're going to actually use the 3-month and 6-month moving averages to predict demand for February of 2016 and find math for both forecasts. So let's go back to Excel and sheet 1. Well, I'm just going to use, I'm not going to use the whole data, so I'm just going to use the data until January 15. And so everything I'm going to do is just going to be for February of 2015, and just because I don't want to just disclose all the answers. So I'm going to just copy this data set and bring it here and paste it. So everything I'm doing is just for January, the first portion of the data set, but you have to do it for the whole data set. Now let's look at how to find the 3-month moving average. 3-month moving average forecast. So in order to make that forecast, you need 3 of the variables, 1, 2, 3 data points. So it's your first 3-month moving average forecast falls on the 4th period. So just put equal sign for the formula and average the first 3, and that's it. You highlight the first 3 and OK it. There you go. Let me make it nice. Center this thing. So your first 3-month moving average is 10.4, and if you click on this and come to the lower right hand side, you can actually drag and drop and you get all your forecasts. So let's say I'm looking for February of 2015. Just notice that you have to do it for February 2016. So this is the forecast using 3-month moving average. Okay, so it's 1209 for February of 2015. Also, I asked you to find a measure of accuracy of this forecast by calculating the MAD. So to find MAD, you need to find a column called absolute deviation. Okay, and absolute deviation is the absolute value of difference between the actual and the forecast. So to find that absolute deviation, equal sign for formula, and we're using the function ABS for absolute value, open parentheses, and click on the actual value on the 4th period minus the address of the 3-month moving average forecast, close parentheses, enter, and there we go. Difference between 11.1 and 10.4 is 0.7, and just like before, we're going to go ahead and drag and drop. Don't go all the way because we don't have an actual for the last period we're trying to forecast. So you just stay right here. This one stays by itself. That's your 3-month moving average forecast. Okay. So let's make it color coordination here. Okay, so we're basically done with 3-month moving average, and we have now I need to also find the MAD, mean absolute deviation. It's going to be equal to the average of absolute deviation. So just go ahead and equal to the average of all the absolute deviations you have here. There you go, and OK it. Here's your math for 3-month moving average forecast. So that basically tells you how good your model is, how accurate your model is. And so I just did this for a 3-month moving average. You have to do the same thing for 6-month moving average, okay? So 6-month moving average basically uses 1, 2, 3, 4, 5, 6 values, and it's equal to the average of the first 6 values. Okay, there we go, and okay it. So do the same thing we did here and find your 6-month moving average and also find your MAD, and you basically have to indicate which forecast has a lower error or higher accuracy. So as you see, you have to indicate find MAD for both forecasts, identify the preferred one based on each calculation, and then indicate is the moving average suitable method for forecasting for this data set, and explain your reasoning. Alright, so 3-month and 6-month moving averages, and find MAD for both of them, and copy and paste, and you put it over here. So basically, you can go ahead and just give me the 3-month moving average forecast and the MAD, and the 6-month moving average and the MAD. You really don't have to copy and paste everything. You can do it if you want to, but you're gonna send me the Excel files anyways as a backup. So as a group, you're sending me the Word file and Excel file, so I know what you have done. Okay, so let's go to the next part, which is part 6. Use exponential smoothing forecast with alpha of 0.1, 0.2, all the way to 0.9 to predict February 2016 demand, and then identify which alpha results the lowest MAD. Okay, so let's go ahead and back to Excel. Let's get, I can copy this thing again and put it on a new page. Okay, copy. I can put it right here and paste it here. That I don't need, so I'm going to delete this. So let's go ahead and need to find the exponential forecast. What I need first is to have a location here for the value of alpha. So I'm going to say, well, alpha is going to be, we're going to start with 0.1, and I'm going to also need the MAD value here, and it's going to be here. Later on, we're going to insert it over here. So let's look at our exponential forecast. So we're going to call this exponential forecast. Exponential forecast. And okay, now the first, you need a forecast to start this exponential forecast. So always use the actual of the first period as a forecast for the first period. So for May 2013, I'm going to use the actual of 9.5 as a forecast. So that's 9.4 is going to be my forecast. So formula for exponential forecast is f sub t is equal to f sub t minus 1. Oh, it's not good. F of t minus 1 and plus alpha times actual minus, so ft minus 1, let's do it like this. Ft minus 1 plus alpha times actual of t minus 1 minus forecast for t minus 1. Alright, let me see if I got this right. So it's just going to be of this, like this, t minus 1 Okay, so the formula is forecast for time t is a forecast for time before that plus value of alpha times actual of t minus 1 minus forecast for t minus 1. So let's build that formula in Excel. So it's going to be equal to, be ready to insert a formula. So the forecast for this period is the forecast for last period. So click on the address for the last forecast for last period plus alpha. So this is my address of my alpha. So click on the address of your alpha, and I like to keep that address fixed so when I copy it, it wouldn't change. So right after you click on the address for the alpha, also click on F4. As you see, it changed from K30 to $K $30. Basically, that means the address is going to be fixed, and then multiply by open parentheses actual of the last period address minus the forecast of the last period address, close parentheses, enter. You should get the same number because these two were the same. Okay, so the first two numbers, if you get a different number, then that means you made a mistake somewhere. So go ahead and drag and drop, and here we go. Now my forecast for the February 2015 is this value. Remember, you're going to do it for February 2016. So this is not the answer that I'm looking for, but this is just a practice to show you what's going on here. Now, also I need to find math. So as before, I need absolute deviation. So let's call this absolute deviation column, and it's going to be equal to ABS open parentheses actual minus the forecast address close parentheses enter. You're going to get 0, and that's correct because the forecast and actual are the same. So move to the lower right hand corner of the box here, drag and drop. Don't go all the way down to the February, just because we don't have an actual here. So just go one less than your last number, and these are your absolute deviations. Now we're ready to actually calculate the MAD again. So come to this cell right in front of MAD equal sign, average of the absolute deviation. There we go, and okay it. Here we go. This is your MAD for alpha 0.1. So as you see here, I've asked you to find this for all the different values of alpha. Okay, so we need to change these alphas and make a table here. So I'm gonna, let's call value of alpha, and we're gonna call this our forecast column and the MAD column. Okay, so your alpha goes from 10% to 20%. I highlight both of these at the same time, and then drag and drop is going to go in increment of 0.1. That's a neat trick to know if you already didn't know that. So go ahead and center it to make it look good. So now for my point alpha of 0.1, I know my forecast is equal to, these are exponential forecasts, is right here. So copy, right click, copy, and paste it, but be careful, paste it as a value, not as an address. So it wouldn't change. So and the math, same thing with math, right click, copy, and come over here, right click and paste value. So I have my alpha, forecast, and MAD. Now the nice thing about what we've done here is if I change the alpha to 0.2, then everything changes. My forecast changes to this new value, and my alpha MAD changes. MAD There we go. So as you see, going from alpha 0.1 to 0.2, we have a new forecast, and actually our math is decreasing. That means it's getting a better forecast. Let's just do the last one too, 0.9, and again, by changing that, everything changed, and copy and paste value, and there we go, copy and paste value. So as you see, at some point here, you're gonna get your lowest math. Okay, you have to say, okay, what math, what alpha gives you lowest math? You have to fill in this table by changing the value of alpha from 0.1, 0.2, 0.3, and so on, and find this. And after you get this, then all you have to do is just go ahead and copy this and bring it to the Word file, and just right here, there we go, you paste it over here, and obviously I don't have everything, so so okay, let's go back to step 7, and that is finding the monthly seasonal indices for demand values using simple average method. So you need to do a little bit of data manipulation in order to find the indices here. So let's go back to our data set, and what you need to do is again, just let's see, take the data, and I'm going to go ahead and make the months here of the year, and then it can be January, February, and so on. Let's see if this thing works. If I highlight these two, oh yeah, this is nice. So it's just going to get all my months here, and let's go ahead and center this thing right here. Let's say center it. So, and so again, I'm just going to use 2013 and 2014. So we're going to do it for the demand data. Okay, so the first starts from May to December. Just remember that. So copy May to December, and this is May to December. Paste it. Alright, I don't need this January here. So that's year 2013. So 2013 data, and then 2014 data. Okay, so 2014 starts from here, 8.3. So that should be like 12 data values. Copy and paste it over here. We have everything go right here, and then I have an extra January of 2015, so I'm gonna copy this and put it over here. So that's 2015. Now remember, you're doing it for more data, so you actually go to January of 2016. So I'm not using all the data, just because I don't want to disclose the correct answers. Okay, so we have, let's just change this to bolder, okay, and a larger font. So for simple average method, you need to find the monthly averages first. So monthly average, It's a straightforward. You just go ahead and equal to the average of, you can highlight all three of them, that's fine. If there's no value here, it just takes it as non-existent. And oops, something happened here. So equal to the average of, let's see if it's working or not. So right here, and okay, there we go. There's our average for our monthly average for January, and if you drag and drop, you're gonna get all of them basically. So these are the monthly averages. Also, you need the grand average. Grand average is going to be equal to the average of the averages that you already have. Okay, so the grand average is equal to the average of the averages you already have. So okay, here we go. So this is a grand average. So seasonal relative, the monthly seasonal index, let's call it, or same thing, seasonal relative seasonal index is simply is going to be equal to the monthly average divided by the grand average. And just make sure your grand average, you need to fix the address for it. So just click on F4 after that. So when we copy it, it wouldn't change. So here we go. These are seasonal indices, drag and drop. And these are the values of seasonal indices. And one way to check yourself to see if you've made any mistake or not, these are 12 months, so seasonal indices must add up to 12. So let's check that, equal to sum of these numbers. So if I have not made any mistake, I should get 12, and there we go, we got 12. So that tells you have not made a mistake, big mistake. So now I have these seasonal indices, and basically they indicate whether a given month has a demand of below average or above average. So if you look at, you see January, February has the lowest seasonal indices, so that basically means you have the lowest sales or demand in February. And let's look at the month with high is like September, is 1.14. Basically that tells you it's 14% higher than average in September for this data set. Okay, just make sure you understand that these are not the correct answers because I've not used all the data sets. Okay, so I need this as your, let's say, we can copy this and paste it in a Word file here, and right here. So these are seasonal indices, and this is very large. You need to just adjust the size of this to make it fit very well in the data set. I don't know what these are. Probably, yeah. Okay, so we have our seasonal indices, and also you need to find the deseasonalized demand by dividing the monthly demand by seasonal indices. Okay, so the way we deseasonalize the data is we divide the demand data by seasonalities. So let's go back, and let's say I'm here, and we're going to I'm just going to copy this into a new page, copy, bring it here, and there we go. Now these are May and January. So make a column here called seasonal index. Now you need to copy and paste the seasonal index you had before, which is over here, from January to December. This is your seasonal index, correct? So copy and paste. What remember is January, so it's going to be paste value here. So that's January to December. I also need May through December, okay? So this is May, right? January, February, March, April, May. So this is May through December. So I'm going to copy this and paste it here again, paste value. And finally, I need January again here. So copy the January index and put it over here. So as you see, I have inserted respective seasonalities, okay? Right in front of the May. This is the May index and so on. So then you need deseasonalized data. So let's call this deseasonalized data or deseasonalized demand. Okay, so that is going to be equal to actual demand divided by the respective seasonality and enter. So there we go, copy, drag and drop. Now I have all deseasonalized demand. So you have to really do that for all your data, not till January 15, you have to do all the way to January 16. Okay, very good. So I have deseasonalized demand, and now going back to our Word file, we need to use regression to perform trend analysis on deseasonalized demand. So this is just a regression on Excel. And let's go back, and now from now on, your demand that always you're going to use for forecasting for the regression parts are going to be deseasonalized demand. Okay, so let's run a regression of time period versus the demand, the deseasonalized demand. Okay, so we're doing the trend projection and finding a trend equation. Okay, very good. So let's go to data and click on data analysis and scroll down to regression. Double click on regression, and then your Y range is deseasonalized demand. Make sure you highlight the heading, and your X is going to be a time period. Okay, and there we go. Obviously, you have to click on label in the first row always, highlight the label, and also click on label in the first row. We need our output in a new worksheet file, so let's call it trend projection model, or you can call it a step 8 or 9 or whatever it is. And also I need residual. Click on residual. We need that to find our math. Actually, we're gonna get our math. So residual, and okay. So here we go. This is our model. This is our equation for trend projection. So basically, this model, you need to write the equation. The first thing, write the equation. So demand is equal to 9.08 plus 0.1348 times times period. Okay, so that's your basically that is your basic regression equation. Okay, let me make it larger so you can see better. So that's the first thing I need to see your equation. Okay, should be able to go from this, the output, to find the equation. Also, is this a good regression or not? Okay, that is indicated by significant F. So significant F basically tells you whether you have a good model or not. And here, this number is 3.97 e to negative 6. That is like a small number, it's like 0.000039. So very small number. The smaller the significant F, usually the cutoff is 1%. If it's less than 1%, that tells you have a good model. So this is a good model, so you have to indicate, this is a good model based on significant F. We can use it. Also, we have R squared. You need to also understand what R squared tells you in a regression output. Basically, R squared is also called the coefficient of determination. In this case, is 68%, 0.68. That tells you that 68% of the variability in the demand is due to trend. So trend over time accounts for 68% of the variability. The higher the better, and the highest value is basically 1. You can't go over 1. All right, very good. So no interpretation of R squared, no interpretation of significant F, and these are residuals. And you can also find MAD here. To find MAD, these are residuals. So find absolute residuals first. Absolute residual is going to be equal to absolute value of the cell right here. So residual is actual minus the difference that we used to get before. That gives it to us. So here we go, these are our absolute residuals, and then you can find your MAD equal to, and it's going to be equal to the average of these values that we have here. So average of these numbers, and okay, and here we go, your MAD is 0.39. So here's the explanation of, so you need to explain right in front of this what this thing is, and then basically I want you to be able to, these numbers are not very important, so you can just go ahead and copy what you have here, copy it and bring it to the Word file and put it right after this part right here, and paste it. There you go. It's a large. So there we go. You have your summary output, and you put all your explanation here in the Word file. All right. Then you need to find seasonally adjusted trend forecast February to April of 2016. So 2016. You have this equation, all right? So your time period for your data set, if you go back to the original data set, you see you have 33 is January 2016. So you need to input 34, 35, and 36 in your equation that you just found here. So there we go. This is the equation. So you need to input 34 and find the forecast. So let me just do it for this one. So let's assume that, so demand is equal to, you can make a table here, and for different values, demand for, let's say, February is going to be equal to, let me just February demand is going to be equal to this number plus this value times, I guess, 34, okay, which gets to 13.37. So I used your 34 because for your data set you have to use 34, 35, and 36. So here's like 3 forecasts for February, March. You're going to use the same equation. You're going to have a different equation than mine because I can use the whole data set. So March demand, you can same way find the forecast is equal to again this value plus this value times 35. All right. So these are the demands, and then you actually you need to go ahead and seasonalize it. Okay. So February, March, April, along the same line, you do the same thing, and make a forecast for February, March, and April. Now you need to go ahead and seasonalize it, okay? So you need to multiply it by the relative seasonal index. So this is my forecast for February, but remember the data set, we use the deseasonalized data set, so there is no seasonality in our forecast. So we need to go ahead and actually find our seasonalities like February, March, and April. These are seasonalities. Copy it and bring it here, and you can put it somewhere here and multiply it by these numbers. Okay, so seasoned forecast is going to be equal to, let's say, equal to this number times this value, okay, right here. So now, since February, it should be just a small number here, let me see if it's correct. February is, yeah, it's very low. So we're gonna get decrease. So to seasonalize it, you multiply, okay? So I guess you can just so these are going to be your forecasts, okay? So find the forecast using the equation and then multiply by seasonalities for February, March, and April to seasonalize it. Okay, very good. So and then I need these forecasts copied and put in the Word file. Okay, now that was the trend, basically trend forecasts. Now let's do our regression. This time we're going to use another variable, advertising, to predict demand. Okay, so go ahead and let's go back to Excel file and go back to our data set that has actually okay, this is again using deseasonalized demand always, and we want to run a regression of demand versus advertising. Okay, so one variable. So go ahead and again go to data analysis, regression. Your y variable stays the same. Your x variable now becomes advertising. Okay, so advertising, and I'm going to change the name of this. Let's clear it. Call it advertising versus demand regression. Okay, so okay it. There we go. Here's your output again. And let me just make it larger for your viewing. Okay, so again we have, just remember these are not the correct answers. So advertising for this model I have, is this a good model? Okay, just look at the significant for my model. Yours may be different, okay? I'm just showing you an example. I'm not using all of the data set. So significant F in this case is 0.13, which is it's higher than our cutoff value of 1%. So that tells the model is not good. Your R score is 11%, that's low. And so altogether, it's not a good model, but I can write the equation as demand is equal to 6.58 plus 0.59 times advertising, all right? So that's the equation in case you need, and then you can go ahead and just like before figure out the math. So also you need math here. Don't forget to calculate the math. All right, and then just copy and paste just like before and bring it to the Word file and put it right under part 10. Part 11 is the same, but this time with diff. I'm not going to do that. Same steps. Part 12 is we're going to run a multiple regression with AIP, period AIP diff and advertising. Okay, and don't worry about MSC. I forgot to take that out. You don't have to find minuscule error. Just math is enough. And period AIP diff and advertising. So the price is not in here, so that's intentional because diff will actually take the effect of the R price in there. So let's go back to the data set and run a multiple regression, and so we don't need price. So basically you have to, let's see if I can, and well, I'm going to insert the column here and put time period right by it, copy and paste the time period. Okay, so let's run the seasonalized demand versus period AIP diff and advertising. Okay, we're not using the demand itself. As I mentioned, we're going to use deseasonalized demand after we find it. Okay, again, go back to data analysis, regression, and did I make a mistake there before? So maybe because that may be the reason my regression was not right before. Let me try that again. So let's try that, because that was strange that the advertising was not a good regression. So let's do it again. So let's test it again. Data analysis, regression, yeah, that may be the problem. So the seasonalized demand is our Y variable, and our X variable is advertising, let's say. Okay. So, yeah, error message because I have the same name. Well, this is much the same. It didn't change. Well, that is fine. So, I guess that was right. So let's go back to our deseasonalized demand versus these variables, okay? So data analysis, regression, and your variables are going to be period AIP diff and advertisement, okay? And you can just clear that. You can put like your step, whatever, step 12 as your the title. So step 12. Alright, so there we go. Here we go. It's our output here.